Now this illustration deals with the grounding electrode. Where there's a separately derived system installed, then you got to ground that secondary side of that separately derived system. But also you have to ground at the service equipment. Now this illustration in 250.30A4 deals with the separately derived system, but notice in 250.50, 250.52, and 250.53, you're dealing with the service equipment to the right. And notice we are connecting into an electrode system there. It could be a concrete encased electrode, it could be the structure building steel, it could be a water pipe, any of those that are listed in 250.52A1 through A7. But now notice we have a feeder going over to that transformer, primary. And the conductors are sized at 125%, as the overcurrent device is sized at 125% for that primary under the conditions of Table 450.3B as in boy of the NEC. Now the secondary side, I still think the first choice would be the structural steel to ground the secondary side of your transformer. It could be a metal water pipe. And notice now in this section, 250.30A4, the water pipe is mentioned first. And the reason for that, if it's not continuous and as shown, and maybe spliced with PVC without putting a bonding jumper over it, it's not continuous. So they want to check that out to see, does it need to be bonded in? If it's not continuous, it needs to be bonded in as well as the structural steel. And then if you couldn't get to the steel, you couldn't get to the water pipe system, and we're just saying if, then you could hit a driven rod, but the driven rod is usually, bonded back into the grounding electrode system in accordance with 250.50. So under these conditions, then we're complying with 250.52A2 and 250.30A4 of the NEC. The sizing of your feeder is required by 215.2A1, A and B, depending on if you have correction or adjustment factors. However, we're going to size it, the conductors and the overcurrent device, in accordance with Table 450.3B, as in boy, under most conditions. But we would naturally go by the design technique. And if you don't do everything according to Table 450.3B, for example, then you'd use the feeder sections of 215.2A1 or say A1B, as you see there. But most all designers will design the conductors and the overcurrent device to that primary to allow the maximum kVA of that transformer to be used. So kind of keep that in mind. And then notice the note, it says building steel should be effectively grounded, and the metal water pipe connection should be made within 5 foot from the point of entry if it is an electrode with 10 feet or more of it in the earth as outlined in 250.52A as an Apple 1. And then notice in the grounding loop, then you are suggested as users of the NEC in viewing this illustration to review 250.20D as in dog, 250.24C as in car, as well as 250.142A as in apple 3. Now, reviewing these sections that you see in the illustration, you get a good handle on what is required for grounding the service equipment and then grounding the separately derived system on its secondary or at the first disconnecting means, as we have reviewed going through these illustrations that illustrate 250.30 in its entirety.